And we'll start. All right. First of all, let's talk about the last week of class. I know some of y'all do y'all spazzing out right about now. And go ahead and write this information down, except for where it says 120 project. Y'all don't have a project, do you? So you don't have to worry about it. Last day of class is Tuesday, November 24th. No, you do not come to class on Tuesday, November 24th. I'll get somebody in this class who'll send me an email. Do we come to class on Tuesday? Of course, I won't reply because I've already covered it after today. But your last day of class is Monday. Your last day of class is Monday. On Monday, two or three things are going to happen. One is your final exam and your last test will start. And it will end on midnight, December the 7th. Homework will terminate on midnight on the 23rd. So therefore, after the 23rd, after Monday, all you got to worry about is the final exam and the last test. The last test will cover whatever I cover up to the 23rd. I believe I will be able to get through with logarithms, in which I will be very happy if I get through with logarithms. So chances are your last test will be on logarithms. So that means we will not do the last unit. So you are not responsible for that homework or that test. I will take it off of the homework, and I will take that off. So again, last day of class for this class is Monday, the 23rd. On Monday, the 23rd, the homework will terminate at midnight, and the final exam and the last test will start on the 27th. On the 23rd and last until the 7th. The last test will cover logarithms. What about the final exam? Well, you have 2 attempts. Usually it's 25 to 33 math questions, no bonus questions. If you want to, they will cover the old test. So if you want to look at your old test, hold on. Who's not in the class? Somebody, I got a message, says, sorry, it's not letting me join the class, but I don't understand. They got a name beside it, unless that was Mr. Cash. Bronson. Oh, man, I don't understand why it won't let her in. Some damn Russians. Hold on a second. I'm trying to get her in. Miss Bronson, are you in?
Yeah, I'm here. Sorry, I don't know what happened.
That's all right, as long as you're in. Okay, now, final exam. 2 attempts. I think I've already covered this. I take the higher of the 2, just like I've been doing all semester. 25 to 33 questions, and those are math questions. And if you want to study for the test, the exam, all you need to do is just go over your old test in Gradebook and hit review. You have 2 hours to take the exam. I only make it an hour. So you've got double time. Everybody has double the time because I make it all just like I do your other test. I give you double the time. And it will be started at 8 a.m. on 11/23, and it will go until 12/7 midnight. That is the final exam and the last test. The last test will have bonus questions on it and logarithms. If you see something funny on My Labs Plus in the next couple of days, go with it. Don't write me an email and say you're confused. If you see something that's to your benefit, what? Take advantage of it. Does everybody understand that? Don't write me an email or a message on Teams that says you're confused about something. Just go with it. And you should be seeing that in a couple of days. Any questions on the last week of class? Okay, so that should add to your anxiety for the last week of class. Actually, I think mine's pretty laid back. At least I'm not trying to get that last unit in the next couple of days. All right, so let's look at the 6.4. 6.4, I'm just going to write it right here. Hold on a second. 6.4 is kind of like 6.1. Most of it's going to be done on the calculator. Graphing logs. Let me ask you a question. What if I gave you the following? First of all, what does a logarithm look like? Well, we talked about that the first week. Let's take out our handy dandy calculator. And let's do a log right quick so everybody can, it should be on your family of graphs, your parent graphs. But we're going to go ahead and do it again. Because I told you that there's two graphs that you should have added. See, I don't know why it's taking so long. Well, maybe I didn't click on it enough. Y'all having Russian problems on y'all's computer today? Russians on y'all's computer. Y is equal 2 to the x. And y is equal to log of x. And I think we did this the first couple of sections. I wanted you to add these to your parent graphs. Okay. But we're going to focus on the magenta one because that's log of x. So I'm going to get rid of 2 to the x. I'm going to get rid of that one. And we're just going to graph log of x. Log of x, close parentheses, and clear. And graph. There's the log of x. Now it starts at 0, 0, -1. Okay. And it takes off and does a swoop. Okay. Now remember that, because if I give you the following problem, f of x is equal to log of x minus 2 plus 6. Somebody tell me what this graph is doing.
Two to the left and up 6.
Say it again.
2 to the left and up 6.
Okay,
That's
2 to the left, you sure?
Right.
2 to the right. So you would take your parent graph and you would move it 2 places to the right and up what? And then you would take that same magenta looking, I don't have it, I guess it's close to one I got. And instead of down here going this way, it's going like that. Now this should be second nature to you because of completing the square and getting it in that form. That's horizontal shift, 2 to the right, and that's vertical shift. What if I was to put a 1/2 in front of it? What would that do? Well, 1/2 is between 0 and 1. 1/2 would make you stretch along the what axis? And compress along the what? So what would that make that magenta do? Would it make it compressed or would it make it stretched out? Make it stretched out, Hubert. So it'd look something like that. What if I put a 2 in front of it? 2 log of x minus 2 plus 6. Well, that would be compressed 2 means compressed along the x-axis and stretched along the what? Y-axis, so that means it would make it look something like that. So let me ask you a question. Is this something that y'all seen before, only it doesn't have a log in it? Have y'all seen this before?
Yeah.
Yes.
Yeah.
Horizontal shift, vertical shift. 1/2 is compressed. 2 is stretched. I'm sorry, is stretched this way. Okay, why? That's all I'm going to ask you for in 6.4. Now you make domain of this function, of the magenta function. Domain is 2 to infinity. Range is from 6 to infinity. And it's increasing from 2 to infinity. It's increasing. So I'm not going to spend a whole day or two on section 6.4 when we've been doing it the whole semester. Okay? The only difference is that log has not been there. Okay? It was x minus 2 third, x minus 2 squared, x minus 2 square root. You know, now it's log. And the only difference is instead of a parabola, you've got a swoosh. I call that a swoosh, whatever you want to call it. So that's what I will test you on in 6.4. So you can look at the, the PowerPoint. Let's see, 6.4. Now, how do you do, let's go ahead and do this also. Let's do let's just look at this one. Well, they're not going to give you much of a, go ahead and write this one down. It says f of x is equal to a to the x. Find its inverse. Well, that's pretty simple. I showed you how to do that. F of x is equal to a to the x. F of x is equal to a to the x. First thing you do is write it in terms of y. Y is equal to a to the x. What's the next step in finding the inverse after you put the y in there? What do? You switch the x and y, Hubert. That's right, class. And now you have an exponent, and you need to rewrite it as a logarithm by the definition of a logarithm. The definition of a logarithm says y equals log base a or base b or whatever of x. And that yields a to the y or b to the y is equal to x. That's the definition of a logarithm. So I have a to the y is equal to x. So that's going to be what? Well, y is equal to log base a of x. So y inverse is equal to log base a of x, or in this case, log of x. Y inverse equals log of x. And that's what they were doing right here. So if you was to take your handy dandy graphing calculator and do a to the x, we already got log of x in there. So a to the x, well, that would, I don't know, you can't put a to the x in there, but you can put 2 to the x or 1 to the x. Well, that's not, no, not 1, 2 to the x. 1 to the x is always going to be 1. There we go. You can see and put the y's equal in yellow, x, the oblique asymptote. You can see they are symmetrical, but you're limited because you can raise a power to any number, but you can't take the square, you can't take the log of a negative number. So that's why you don't have a blue going down through here like this. Okay. So make sure you can graph those two. And make sure you know the horizontal and vertical shifts. And that's what they do in this section. I'm not going to do that because they're showing you the inverse, and that's fine. And you can do, you can't do log base 2 of x, but you can do log of x over log of 2. Which we just did that. So log 1/2 x, if you wanted to graph this, you would graph this as log of x over log of 1/2. So I'm going to take my handy dandy calculator. Parentheses, log of, I don't forget what it said. Log of x over log of 1/2. That's your change base formula. So log of x close parentheses divided by parentheses, well, log of 1/2. For some reason I can't type today. Log of 0.5 and graph. That's your graph right there. So most of these can be done on the calculator. You just got to know how to type them in. Of course, the inverse to that one would be log 1/2 x would be 1/2 to the x. And you could do that if you wanted to. One divided by 2, close parentheses, caret to the x. So hopefully y'all can see that most of this can be done on the calculator. So any questions? Question on that? Everybody good? Nobody's going to talk. Thank you very much for the input. I'm looking for something that might be, find the domain, set the inside equal to 0. X minus 1 is equal to 0. X is equal to 1. So you can use 1 and 2, but you can't use anything below 1. So X has to be greater than 1. Just so long as you don't put a negative in here, you're all right. So X has got to be greater than 0. Then somewhere they're going to ask you for vertical. Okay, here you go. Using the equation 2 to the y plus 1. Well, I thought they were going to. That plus 1, is it connected to the y? No. So it is a horizontal shift. I mean, a vertical shift. Well, it'd be horizontal since it's backwards. It's an inverse function. But I won't ask that on the test. Same thing there. And they may give you one like this. Natural log of x squared minus 4. Take your calculator. Y is equal. Clear. Clear. Y is equal to natural log of x minus 4. And graph. There it is. Now, why is it at 4? Because x minus 4 is equal to 0. You can't use anything less than 4 because it will give you a negative. Simple as that. Now, the inverse of that would be this side right here. And of course, you don't need that because they're not asking you for it, but they're just showing it there. This is the natural log. And here's another one where they say find the inverse. And if you want to do that one, we can do that one. Y is equal to negative 2 to the x plus 3. F of x is equal to, negative 2 to the x plus 3. Okay, so let's take it back to our handy dandy. So y is equal to negative 2 to the x plus 3. x is equal to -2 to the y plus 3. And x minus 3 is equal to -2 to the y. And you could divide that by 2 by -1. And -x plus 3 is equal to the y. And now you have definition of a logarithm. So x is equal to a to the y gives us y is equal to log base a of x. Well, this is x right here. So we have 2 to the y. So y is equal to log base 2 of -x plus 3. So I can tell you right now on 6.4, what am I going to ask you to do on 6.4? The same thing I'm going to ask you to do on the 6.1 and 6.2. 6.4, I'm going to ask you to do a couple of things. I'm going to ask you to make sure that you can graph a log or natural log on your calculator. Make sure you know your horizontal and vertical shifts. And make sure you can find the inverse function. Okay, so I'm not going to spend a lot of time on 6.4, just half the class maybe, and that's it. Because I know you can do this, and I know you can do this, and I showed you how to do this just now on 2 problems. So you're talking about probably 2, maybe 3 questions on the test. The bulk of this test is going to come from 6.3 and 6.5. 80% of the test is going to come from those 2 sections. Okay, so, and we covered 6.3 rewriting, and 6.5 is nothing but rewriting, but you got to do it in an equation. That's what we're fixing to start today. I want to spend the rest of our time on 6.5. Any questions on 6.4? Everybody was sick this weekend. Missouri, University of Missouri was sick. And who was Clemson supposed to play? They were sick. I guess we just all need to just stay home. Clemson, was Clemson on a bye week, or were they not supposed to play? Georgia was supposed to play somebody. I can't remember. Oh, LSU, wasn't it? Or Alabama was supposed to play. I can't remember. Yeah. And it was also Georgia and Alabama were all supposed to play the Tigers. Georgia was supposed to play the Missouri Tigers, and Alabama was supposed to play LSU Tigers. Boy, can you believe how much a team sucks without their quarterback? LSU just sucks. A couple of coworkers are trying to get covered for the last game. I don't understand the question. I mean, I don't understand what you were saying. They're trying to get covered. In other words, they want to go to the game. Okay. Now, 6.5. This is where the rubber meets the road, 6.5. And I can't find it. I hate when I lose stuff on the computer. There it is. Now I'm going to spend at least this week in 6.5 because this is where you're dealing with equations. Just some reminders of some key, and I already showed you these. But remember that if you have an exponent, if you have an exponential law and you have the same base, then you set those denominators, you set those exponents equal to each other. Let's go with 2, or let's go with 4 to the x power is equal to 2 to the 5th. Okay, this is exponential. And that can be rewritten as 2 to the 2nd to the x power is equal to 2 to the 5th. 2 to the 2x is equal to 2 to the 5th. And yes, this is a test question. I'd love to put these on the test because people forget them. If those bases are the same, you can set those exponents equal to each other. So 4 to the 5 halves is equal to 2 to the 5th. That's a test question. That could be a test question in 6.3 because of the law of exponents. And the same thing with a logarithm. If you have log base b of 5x is equal to log base b of 10, then those bases are the same. And if those bases are the same, you can set the, I don't know what you call it, whatever you're taking the log of, you can set those equal to each other. Now you put these two properties with the properties that you learned in 6.3, and you've got 6.5. Same thing here. $125 to the x power is equal to 5x. $125 is a multiple of 5 to the third power. And basically you get 3x is equal to x. subtract that, bring that over, 3x minus x is equal to 0, and that would be 2x is equal to 0, x is equal to 0. So you could actually solve that. This one is not, because you don't have the same base. We would take the log of both sides here. And we'll get into that later. So here's one. Okay, they're going to go ahead and do it. So 7x is equal to 12. Now, you could take the log of both sides. Log of 7x equals log of 12. Let me tell you something about this right here. You need to write it down. Somebody tell me what this is in mathematics. You take the log of a number, what do you get? What does the log of a number give you? Come on, I want y'all to say something. Oh gosh, I made a mistake. That's 7 to the x. It's going to make a difference. Hold on. 7 to the x. There we go. But anyway, what does that log of 12 give you? It gives you a number. Okay, the reason I want you to write that down and highlight it is because a lot of times in the future, you're going to see the log of a number, and sometimes it'll be in an equation, and you're going to look at it like, oh no, what do I do? Remember, the log of a number is just another number. And if you go ahead and do that in your calculator, you're going to have a decimal or a number with a decimal or whatever. But it's easier to work with the number than it is the log of 12. So when you're dealing with, when you see the log of a number, I want you to start making a note. The log of a number is just a what? It's just a number. So if you can change that into a number and make the algebra a whole lot easier, then do it. Now, here's an example of 6.3 at work. I've got this. What can I do with this x right here? Somebody tell me. I want you to talk or use your chat. What can I do with that x right there in that we learned in 6.3? So somebody needs to say, I have no clue, or you don't want to talk, or put it in front using what, Mr. Cash? What rule? The power rule. I think all y'all not hung over, are you? Y'all just don't feel it today. Is that it? X times the log of 7 equals log of 12. Oh, there's another number. So technically, what do we have? So you could look at this all day long and go, oh, what do I do? But look what happens. Log of 7, 0.845. 0.845x is equal to log of 12. 1.08. Now, if I asked you to solve this, you might look at me and go, I don't know exactly what to do. But if I gave you this, what would you do next? What would you do next here on this problem? Pre-algebra, algebra 1 question here. Have I offended y'all or some way or made y'all mad or thank you? Thank you, Mr. Cash, again. Mr. Cash is the only one talking today. Divide by 0.845. So what am I going to do on this side to get x by itself? What is up with y'all today? Y'all usually talk to me. Miss Davis, what's wrong? Everybody's.
I'm sorry. I'm listening. I had to come to work.
Oh, okay. You're just listening.
Sorry.
Okay. So what I do right here to do the same thing over here. Divide by the log of 7, Hubert. That's right, class. So x is equal to the log of 12 over the log of 7, or x is equal to 1.08 divided by 0.845 That's why I tell you, when you see the log of a number, sometimes it might be beneficial to you to go ahead and change that into a number. So that way you won't get stuck and go, oh gosh, I don't know what to do here. But if you turned it to a decimal, you have a pre-algebra problem. That right there is a test question. Y'all make a man feel bad. I feel like I've done something to y'all. I feel like a boyfriend don't know what he's done wrong, or a husband don't know what he's done wrong. And I still get the silent treatment. Okay. Appreciate it. Appreciate the silent treatment, guys. It really makes me feel good. It's always good to have the silent treatment. And you can do that also by typing in 12 and 7 to the x and seeing where they intersect right there. Seven to the x less than 12, you do the same thing, except in other words, it'll be instead of x is equal, it's going to be x is less than whatever that came out to be, 1.227. Okay, let's get to another question. There we go. Here is, I'm going to let y'all do this one. This is a test question. This is exactly the kind of question I would put on a test. 2 to the 3x plus 1 is equal to 3 to the 4 minus x. Take the log of both sides and work it. Give you a couple of minutes. I appreciate you, Mr. Cash. I appreciate you interacting. One day you're going to have a nice office. The rest of these people, they're going to have a closet office. Still no comment. Take the log of both sides. Log of 2 to the 3x plus 4 equals the log of 3 to the 4 minus x. These two guys are going to come out front. Oops, hold on. Oh, me, I've got too many monitors. Hold on a second. Let me get my monitors fixed back. There. Okay, so I'm going to bring this one out front using the power rule and put in parentheses 2. 3x plus 1 log of 2 equals 4 minus x log of 3. Now what? Now what? That means either say, I have no clue, or tell me what to do next. Turn, exactly, Mr. Cash. Turn the log of 2 and log of 3 into what? Numbers, Hubert. That's right, class. Now, if you don't want to do that, you can just distribute the log or distribute the decimal, whichever one you want. I'm going to distribute the log. So 3x times the log of 2 plus the log of 2 is equal to 4 log of 3 minus x log of 3. Now you could have, if you turn that into a decimal and that into a decimal, the only thing is you want to carry those decimals to the 10th place in your calculator, because chances are they're going to want an exact answer or a very, very detailed answer. So you might want to carry at least 4 or 5 digits. All right. So I got to get all my variables on one side. Remember, this is a number and this is a number. So you could treat those like numbers algebraically. And I'm going to bring this one. I'm going to bring this one over. Why am I going to bring this one over? Why did I pick negative x to the log of 3? Why did I pick it to come over to the other side? Why did I pick negative x to the log of 3? Why did I pick it to come over here? What does it have in it that I don't like? Come on, people. You can say one word. Thank you, Mr. Cash. Y'all suck today. 3x log of 2 plus x log of 3 is equal to 4 log of 3 minus log of 2. Now, how in the world do I get this to work? Well, what's in common? An x. Let's factor it out. Three log of 2 plus log of 3 is equal to 4 log of 3 minus log of 2. And now just divide by all this trash. So I'm going to rewrite that. X times 3 log of 2 plus log of 3 equals 4 log of 3 minus log of 2. So now I'm just going to divide by 3 log of 2 plus log of 3, 3 log of 2 plus log of 3. So x is going to be equal to 4 log of 3 minus log of 2 over 3 log of 2 plus log of 3. And of course, you can take your calculator and do the math at the end, or you can do the math at the beginning right here. It depends on what you want to do. But you'll get the same answer. Now, I don't know what they did. Let's see what they did. Yeah, they did it at the end. So x is equal to 1.165. Okay. Now that was 2 test questions right there. 1 and 2. And yes, they get very long. So you better make sure you can crawl before you walk. All right, let's take the attendance and shut her down.